Ready, Joaquin?
Yes. I was thinking about how long it would take for me to make 32,000 chess pieces if I had to use the manual lathe, right?
Well, the truth is, it would take you a while. That's why we're going to use the CNC. But we have to learn the design code.
You mean how to program it?
Exactly.
Okay, shall we get to work?
Let's get to work. Joaquin, based on what we've seen, what are the steps for carrying out this project?
You're testing me, aren't you? You want to see if I understand anything about what you've been teaching me. I'm going to surprise you. It all starts with the design of the piece and its representation in the plan. With this information, we choose the productive processes we're going to use, milling, cutting, etc. And then we choose the machine we're going to use, and then the tool selection and the technological parameters. Wait, don't tell me, I know. Then we have to choose, and we have to design the program for the CNC. But we haven't seen that yet.
Excellent, Joaquin. You're right. Now we have to talk about CNC programming. To make the CNC program, we have to follow the ISO standard, also known as the G code. This standard that we're defining is the communication language between the operator and the CNC. Basically, it is how the operator is going to communicate the trajectory, the coordinates, and the technological parameters to the CNC so that it can control the machine. Therefore, Joaquin, based on the selected tools, we're going to define the trajectories. The trajectories will be marked by points and their associated coordinates. Then we need to define the technological parameters that the tools will use between both points. And finally, we must select an ISO code that enables us to communicate all of this information to the CNC. Come on, Joaquin, let's talk a little bit about the structure. A CNC program consists of sequential instructions that describe the movement of the machine. These instructions should contain all of the information so that the machine can carry out machining.
And what does that include?
Well, and this includes the movement functions, auxiliary functions, such as turning the coolant on or off. These functions are given in the form of blocks, which are numbered sequentially.
And what is the block made up of?
Good question. The blocks are made up of, here, I can show you on the screen. They are made up of an initial number that describes the block number, and then the functions, such as, for example, G90, which defines the coordinates. If they are absolute or incremental, M03, which is an auxiliary function or miscellaneous function, which turns the spindle rotation on or off. Then we have the G00, which is a fast movement function. M05 turns off the spindle, and then M30, which is an auxiliary function to finish the program.
Are there any rules to follow when it comes to setting up the blocks?
Yes, you have to consider the following restrictions. They must contain only one tool movement. They must contain a unique cutting speed. Also, they must only contain one tool or spindle velocity. And finally, the block numbers must be sequential. Got it?
Yeah, perfect.
Hey, Joaquin, meditating?
No, I was going over everything that we talked about today. We talked about the stages of program development. We talked about the trajectory, which is like the route that the cutting tool has to follow during all the work. This is based on its points and its coordinates.
That's right.
We also talked about the technological parameters that are, for example, the cutting speed, the depth of cut, and the
forward movement. Yeah, good.
Fine, Jorge, thanks. I'm going to write this down. Forward movement. Then we talked about the codes, which are the information that we are going to give to the CNC so that the machine does the work sequentially, block by block. We saw this, didn't we?
Perfect. Excellent summary.
Shall we continue tomorrow?
Okay, of course.